Hello everyone, welcome back to Arduino Learning at the Student Room branch of the IEEE at the University of Toronto. Assuming that you have all the basic knowledge from the first two lessons, today in this lesson, we'll cover how PWM output works, what is used, how analog input works, what is used, and how to use those concepts in electronic devices. Let's get started. So first of all, you guys need to know what is PWM. PWM stands for pulse width modulation. It is a technique for getting analog results by using digital input. It controls or adjusts the power going to the devices by rapidly turning them on and off. The average voltage depends on the duty cycle or the amount of time the signal is on versus the signal is off. If you look at the right hand side picture, let's take the 50% duty cycle as an example. In one box, normally we're gonna call it one period. You can see that half a period, the signal is 5 volt. Another half period, the signal is 0 volt. So if we keep the period the same like this, the output voltage is gonna be half of the maximum one, which is 2.5 voltage. With this technique, we can use it to control the speed of motors, LED brightness, and the servo motor position. So for now, let's move on to the analog input. Analog input helps us read and interpret information that can be anywhere between the lowest and the highest value of the device. It's useful when we want to work with sensors or devices that give us continuous information like temperature or the position of the potentiometer. I know that you already have learned the digital input, so what is different between two of them? Digital input deals with discrete values such as on, off, or high and low, or 1 and 0. However, analog input deals with continuous value. For example, in potentiometer is from 0 to 1023. So it can be anywhere between them. 0, 1, 2, 3, etc. until 1023. So for now, let's dive into one of our example. In this example, we use the potentiometer to control servo motor. Now let's open the Walkway website. In the Walkway website, as you can see, I have one potentiometer and one servo motor that connect to the Arduino. If you want to find and add these parts, you can just click on this button, scroll down and find it, or you can type servo for servo motor or potentiometer for the potentiometer. First of all, we've known that the potentiometer will reply back with a number between 0 and 1023. Normally, in order to control the servo motor, you need to input or write the degree that you want and then run the program for the servo motor. However, with the potentiometer, we can control it physically instead of just typing the code. As you know that the servo motor rotates from 0 degree to 180 degree, and a potentiometer give Arduino values from 0 to 1023. So we need to do some math to match these values together. So if you look on the left hand side, that is my code in there. First of all, in order to control the servo motor, you need to include the servo library. And then line number 3, I just simply want to use the digital pin 11 for the servo motor. Because if you take a look closer to the digital part, over here. With the symbol, it means that that pin supports PWM signal. So pin 11, 10, 9, 6, 5, 3. Using these pins is going to help you to control a PWM signal better. So, and at line number 5, the pot read, I use it to store a current value of the potentiometer. So now let's skip into line 23. Use the current value of the potentiometer. I divided it with the maximum value of the device and then time it with the maximum value of the servo motor, which is at 180 degrees. After converting the values of the potentiometer to the degree of the servo motor, we will input that value to the servo motor by using the right function. It will convert the value to the PWM to control the servo motor. Moreover, in case you want to see the current value of the potentiometer, which is useful and convenient for you for debugging, you can print it to the series, which is line number 21. Now let's see the result. So for now, with a similar concept, why don't you guys try to do some experiment by controlling one LED to become brighter and another one to become dimmer by using the potentiometer. Remember that the LED brightness value maximum is 255, while the lowest one is 0. So don't forget to convert the value, okay? So let's pause the video and resume it when you have your own answer. Welcome back. So let's look at one of the answer that I prepared for you guys. In here I have two LED, one green and one red. Both of them I connect to number 5 and number 6 pin. And with the potentiometer, same as the previous example, I connect it to A0. I hope that you have the correct answer for the brightness, which is take the input from A0 divided by the maximum value of potentiometer, which is 1023, and then you time it with the maximum value for brightness of the LED, which is 255. And then I'm gonna write to the LED the brightness of red to become brighter, while the green one is become dimmer. Simply just take the maximum and minus the brightness. Let's see the result. As you can see that at the value 0, green has the maximum brightness, while red does not turn on. If I turn it, as you can see that bright, the red one is brighter, a little brighter, while the green one is dimmer until the value is 255. The red has the maximum value of brightness, while the green one is turned off. For now, let's see if I change into the non-PWM pin. For example, if I choose, let's see, number 8. And of course, don't forget to change it in here as well. Let's see the result. As you can see that red LED does not turn on or have any brightness when you try to turn the potentiometer in a halfway until the next halfway. And it keeps that brightness, do not become dimmer or brighter. So remember, be careful with the pin that you want to choose. So for now, let's start into another exercise for you guys, which is a little bit challenge that we're gonna use a slide switch to decide which LED become diamond. So in order to use this one, let me show you how to use it. For the middle part, I'm gonna connect with the ground pin. The left one, I'm gonna connect with any digital pin. Let's take 5 as an example. And the right one, I'm gonna connect with number 2 pin. So I'm gonna give you a sample one. If digital read of the left one, so in my case is 5, is equal to 1, you're gonna decide which one become brighter and which one become dimmer. Else if digital read of pin 2 equal to 1. So the reverse way. For this part, if anyone familiar with programming, you can use else, because as you know that digital read can only be either 0 or 1, right? The next part, the last part, is that in the setup for the pin mode, you need to use input pull-up. So for example, let's take the left one, which is 5. You need to have this one. Okay, same thing for the right one. So for now, let's pause the video a little bit and resume when you know the answer. Welcome back. I hope that you have figured out your answer already. Now let's look at one of the solutions that you can use to solve this problem. I did not really change much about the coding part. I just simply add the pin mode number 8 and number 7 to have input pull-up, and add the conditional part in a loop part. If the digital read of pin number 8 is 1, it means that the top part of the toggle is going to the right. So my red LED is become brighter while my green LED is become dimmer. Otherwise, if the top part of the toggle is going to the left, my green part LED is brighter while the red one is dimmer. Let's look at the result. So for now, first of all, you can see that the top part of my toggle switch is on the left side. It means that the digital read number 7 is 1. So the green LED is brighter while the red one is dimmer, right? I am at the 0 position of the potentiometer. So the red part is at the brightest one. Now if I rotate, as you can see that the green LED is start to brighter while the red one is dimmer until the maximum position of the potentiometer. Okay. If you have the correct answer, congratulations. Otherwise, it is fine because you're still learning. So let's end up. In summary, after the lesson today, you understand how PWM output works, how analog input works, and how they use both of them, and able to use the electronic devices. Congratulations for finishing this lesson. For now, you have a good knowledge about PWM and analog